I wanted to work on a big problem, and I knew that there was very little that could be done for people with spinal cord injury. We're very interested in delivering drugs just to the spinal cord, but if we deliver drugs by the blood, they won't cross what's called the blood-spinal cord barrier. And if you inject right into the spinal cord, you're going to damage it. So the best way is to deliver drugs into this fluid-filled cavity that surrounds the spinal cord. But there's flow there. So how can we deliver a drug to that cavity without it being dispersed throughout the entire central nervous system? So what we do then is we disperse our drug or our therapeutic into this very fast gelling polymer. A gel, a hydrogel, is just a water-swollen material. Think of Jell-O. But instead of waiting an hour or two for the Jell-O to set, we have something that will set in form immediately, and we can inject where we want it to go. Another challenge for us is how do we get sustained delivery? So we've incorporated nanospheres filled with a therapeutic or a drug that itself will slow the release. In another area, we're creating these three-dimensional scaffolds, still starting with hydrogels, still these water-swollen materials, as a way to guide where the cells will grow, with this idea of developing tissues for transplantation. This building, the Donnelly Center, is an interdisciplinary building. Every floor is a mixture of different fields. Some labs are more focused on proteomics, some are more focused on stem cell biology, some are focused on more bioengineering. So having a building that brings all of these disciplines together, it's allowed us to do things that we wouldn't have been able to do on our own. It allows us to ask questions and answer those questions in multiple ways. You know, it's not just engineering, it's not just chemistry, it's not biology, it's not surgery, it's not animal models, it's all of those things together. I've been able to assemble tremendous talent in my lab. I feel great about that. You know, my lab, we work as a team. We all brainstorm on ideas. We all try to problem solve together. So it's great. They're fantastic.
When students graduate with either a master's or a PhD, we retire their lab coat, similar to retiring the jerseys from hockey.
What I've learned over the years is it's very complex. Sometimes I think, well, if I really knew how complex it was, I probably wouldn't have been, you know, as adventurous. But at the same time, that's what makes it so exhilarating, and that's why there's so much potential and so much promise.